Shape and outliers. When we look at a histogram, there are various features that we can pick out. For example, here we can see a peak, that's the highest point. A histogram with two peaks is called bimodal, and this is often the case even if the peaks are not at exactly the same height. I've mentioned that here, it's not necessary for the peaks to be equal in height. If there are more than two peaks, the histogram may be referred to as multimodal. Here we have a symmetrical histogram. Note that this histogram shows perfect symmetry, but perfect symmetry is not necessary for a histogram to be referred to as symmetrical, just if the overall impression gives you that it's reasonably symmetrical. It may be very, very slight differences. This type of diagram is said to have positive skew. Note with this one that most of the data is at the left-hand end, and then it's stretched out in the direction of the positive x-axis. That's why it's called positive skew. With positively skewed data, sometimes referred to as skew to the right, and we can see that because it's pulled out to the right, most of the data is at the left, as we mentioned, and it is then stretched to the right. Negative skew is the opposite. Most of the data is at the right-hand end, and then it's pulled to the left. That's towards the direction of the negative x-axis, was where it gets its name from. So with negatively skewed data, which is sometimes called skew to the left because it's stretched out to the left, most of the data is at the right hand, and it is then stretched to the left. An outlier is a piece of data that does not seem to fit with the rest. When describing the histogram, we can describe the main body and note that we are ignoring the outlier. The actual definition of an outlier is more complex than this, but this will suffice here in this section. This situation will be referred to as clusters and gaps. We can see clusters here and a gap in the middle. Some histograms may have none of the features that we've outlined so far, but that in itself is worthy of comment and something to mention. Now we're going to consider center. Usually when discussing the center of the data for a histogram, we calculate the median. It is also possible to calculate the mean, or at least an estimate of the mean if you've got group data, and state the mode. We will look at these later. Spread. The spread is the range of values, or at least one measure of spread is the range of values. Largest minus smallest, we've met this before, for single value data. Higher end of the upper interval minus lower end of the lower interval if we've got group data. So what we're saying here is you might have data that goes from 0 to 9, and then it goes from 10 to 19, and so on. And let's suppose the last one is 50 to 59. Well, first of all, we can't have gaps in a histogram. So actually, what we have is negative 0.5 up to 9.5, and then 9.5 up to 19.5, and this last one would be 49.5 up to 59.5. So if this was our data, then we would do this one, take away this one, and that would give us 60 as an estimate of the range. This measure is known as the range, as we've mentioned. We'll discuss other measures later in the course. There are other measures of dispersion of data, but for now we're just going to stick with the range.